The James Webb Space Telescope is upsetting the apple cart. All of a sudden, we realize that we may have to rewrite all the textbooks about the beginning of the universe. It has been 2 years since NASA's James Webb Telescope gave us a stunning first look at the depths of our universe. In this video, renowned physicist Michio Kaku unveils a monumental discovery made by the James Webb Space Telescope that could reshape our understanding of the cosmos. We expect the James Webb to make great discoveries, but imagine if we're the only place with intelligence in this galaxy. After years of anticipation, the JWST has finally captured groundbreaking images and data from the edge of the observable universe, revealing secrets that have eluded scientists for decades. Imagine a universe that is infinitely large. Put yourself in the middle and you're going to be watching that object being born. The James Webb Space Telescope has reportedly spotted galaxies dating even further back. What lies at the farthest reaches of space? How does this discovery impact our knowledge of the universe's origins, structure, and fate? Where are the aliens? That's one of the Fermi paradox questions. The inquiry into the age of the universe stands as a cornerstone in cosmology. It is a profound quest to understand how long the universe has expanded since the monumental Big Bang. This explosive event gave rise to everything observable in the cosmos today. Throughout history, the universe's age has been a subject of intense debate, even within the scientific community. However, contemporary consensus among most cosmologists indicates that the universe is approximately 13.8 billion years old, with an uncertainty of less than 1% regarding the duration of its expansion since the Big Bang. Determining this time frame commonly involves two primary methods. The first method involves assessing the universe's expansion rate using the Hubble constant, a metric derived from observing the velocity at which galaxies are receding from us. By estimating this movement, scientists can approximate the time that galaxies took to arrive at their present positions. The second method involves the examination of ancient stars in the universe, found in entities like globular clusters. Scientists can ascertain their ages with a high degree of certainty by analyzing factors such as brightness, color, and rotation rate in these ancient stars. By employing these methods, astronomers establish a minimum age for the universe, shedding light on its origins. Both methods provide compelling evidence that the universe is approximately 13.8 billion years old, with a margin of around 21 million years more. Moreover, this age estimate aligns with numerous other observations and models regarding the universe's current state. Notably, it fits well with cosmic microwave background radiation data, representing the earliest light signatures we have captured from the universe post-Big Bang. However, despite the unity of results from these cosmological models, specific astronomical observations defy this estimated universe age. Some discoveries stand in contradiction, challenging our current understanding. A significant case in point is the star identified as Methuselah. In a study published in 2013, scientists calculated Methuselah's age to be 14.5 billion years, exceeding the widely accepted age of the universe. Critics of the Big Bang theory frequently emphasize this anomaly as a possible imperfection in our comprehension of cosmic origins. Though Methuselah's existence might seem at odds with the Big Bang theory, critics often neglect a crucial factor: certainty. A more precise calculation places Methuselah's age at 14.45 billion years, with an uncertainty of 0.8 billion years. Over time, these measurements are becoming increasingly precise. However, the current estimate accounts for the moment, assuming the maximum uncertainty of 0.8 billion years. Methuselah fits within the acknowledged age range of the universe, approximately 13.65 billion years, but if the uncertainty is considered in the opposite direction, the star markedly exceeds our existing estimates, posing a significant challenge to current cosmological models. Another recent complication for astronomers is a discovery made by the James Webb Telescope. It stumbled upon a cluster of galaxies believed to have originated merely about 300 million years post-Big Bang. While this time frame aligns with the current estimated age of the universe, the young age of these galaxies challenges our preconceptions about the formation of galaxies of this magnitude. Conventional wisdom regarding the formation of galaxies suggested their existence at this stage was implausible. They appeared more advanced in development than previously deemed possible within that era of the universe. Remarkably, They endured intense radiation and collisions with other celestial bodies. Consequently, these galaxies earned the moniker the impossible galaxies. The prevailing sentiment from these discoveries suggested a need for cosmologists to reevaluate their models concerning early galaxy formation, and some questioned the accuracy of the JWST findings. However, what if our current assumptions are incorrect? What if these stars and galaxies are attempting to tell us that our understanding of the universe's age is fundamentally flawed, but we are hesitant to acknowledge it? Rendra Gupta's name was relatively unknown until recently. However, that has changed as Gupta, a professor of theoretical physics and cosmology at the University of Ottawa, is on the brink of making history. He is the only one offering two coherent explanations for the existence of dozens of galaxies deemed impossible at the outer limits of the known universe. Gupta's approach to resolution is straightforward, grounded in two theories that have been known for a century but were not taken seriously at the time. If Gupta's propositions prove accurate, we may need to adjust ourselves to an entirely new number for the age of the universe, 27 billion years, with an uncertainty of approximately 40 million years. Gupta substantiates his claims with compelling evidence. The implications of this discovery would be profound for the scientific community, particularly for those who have long adhered to the Big Bang theory and the prevailing estimate of the universe's age at 13.8 billion years. Should Gupta's study prove accurate and confirm a minimum age of 27 billion years for our universe, the implications would be monumental for our understanding of the cosmos. Numerous existing theories and models would need reassessment. Some would prove incorrect, while others might undergo revision and updating. This wouldn't merely translate to an increased workload for scientists. These advancements could also present an opportunity to address long-standing questions and mysteries about the universe's origin that have eluded us until now. For instance, an enduring enigma in cosmology revolves around what existed before the Big Bang. If the Big Bang marked the start of time and space, the question of what preceded it doesn't seem very smart. However, a deeper understanding becomes imperative if the Big Bang was not the absolute beginning but rather a transition between universes or the start of a multitude of universes. Perhaps there was a pre-existing universe before ours, or our universe originated within a much larger structure, something like an ancient multiverse-like entity with parallel universes and galaxies older than our universe. What if there are stars and galaxies scattered across the cosmos that predate the very existence of the universe? The concept might seem paradoxical, and indeed it is. However, these observations are not mere speculative musings but founded in reality. As mentioned earlier, a solitary star, Methuselah, defied the expected age of 13.8 billion years. Researchers initially grappled with the possibility of a measurement error in an attempt to rationalize this anomaly. Then, in July 2023, the James Webb Space Telescope made startling observations. Dozens of galaxies seemingly older than expected emerged in its lens. These galaxies purportedly existed a mere 200 or 300 million years post the presumed Big Bang. Intriguingly, they exhibited extraordinary order and luminosity characteristics typically associated with galaxies evolving in the universe's early stages. Ordinarily, galaxies require billions of years to develop. When scientists traced back the developmental timeline of these seemingly advanced galaxies, they appeared to precede the universe's age. While some speculations entertain the notion of these galaxies as turbo-developers, such explanations lack serious consideration. The revelations from the James Webb Telescope suggest a different narrative that challenges the established belief in the universe's age or even questions the very existence of the Big Bang. Presenting his solution, Rendra Gupta has stirred enthusiasm among scientists since the summer of 2022. The prospect of a new worldview challenges rooted theories that many researchers have clung to, prompting a reevaluation of established beliefs. As scientists grapple with the potential disruption of their current understanding, sleepless nights may become more common. Regrettably, not all astronomers and cosmologists are ready to embrace these discoveries as transformative. Some still cling to older explanations, resisting the call for innovation in the wake of James Webb's observations. Rendra Gupta stood apart from those dismissing the possibilities as impossible. He swiftly offered a plausible explanation. Gupta drew inspiration from a theory formulated by Swiss scientist Fritz Zwicky in the 1920s. Zwicky's research on the red shift of galaxies led him to conclusions diverging from his contemporaries, like Edwin Hubble and Georges Lemaitre. As light moves through space, its spectrum shifts from white to red over extended distances, causing the oldest galaxies to appear reddish in cosmic images. In contrast, the nearest stars emit a white or blue-white glow. Edwin Hubble discerned more than just the pure distance to us in the red shift, paving the way for new perspectives in astrophysics. He believed he had evidence that these ancient galaxies were not only present but also moving away from us. This observation led to the development of the Hubble constant, describing the rate at which the universe expands. However, despite being a cornerstone of the Big Bang theory, the expansion itself has yet to be conclusively proven, and skepticism persists. Nevertheless, the prevailing notion is that the universe has been continuously expanding since the Big Bang, an idea that Zwicky interpreted differently. Zwicky was convinced that light loses energy during its extensive journey through interactions with other particles, resulting in a red shift. Importantly, this mechanism doesn't follow an expansion of the universe and is seemingly incompatible with the Big Bang model. However, Zwicky's hypothesis explains why the James Webb Space Telescope observed highly developed galaxies at the edge of the universe. In Gupta's theory, he has taken up Zwicky's hypothesis of tired light. Like Zwicky, he doesn't believe that the universe is expanding at a speed approaching the speed of light. Instead, the galaxies merely seem far away because the light they emit has lost energy over time. Additionally, the movement of light is not purely linear but rather curved, suggesting that the galaxies observed by the James Webb Space Telescope are not at the universe's edge, contrary to popular belief. In Zwicky's theory, no edge of the universe exists. Furthermore, these galaxies might be closer to our Milky Way galaxy than previously assumed. This also means that our galaxy could have a lifespan exceeding the current estimate of 13.8 billion years, likely due to gravitational lensing. This phenomenon, known since the early 20th century, distorts light's path around massive objects in space such as stars, black holes, or entire galaxies. These objects act as lenses, bending light so that it doesn't travel in a straight line but curves, ultimately leading to a significantly longer journey. This mechanism can effectively double the duration light takes to reach us, altering our perception of time. For instance, when observing the horizon from a distance, the curvature of the Earth makes it seem farther away, although the observer remains at the same distance. The appearance of older galaxies in the universe's supposed early days could be explained by the enormous lensing structures, which suggest a far larger universe than estimated. If this hypothesis holds, the universe could be more than twice as old as previously assumed. According to the most recent studies, the estimated age is around 27 billion years, with an uncertainty of about 2 billion years. Such a massive revision would mean that the expansion rate of the universe, the Hubble constant, would need reevaluation. Other theories regarding the formation of galaxies, stars, and planets could also be significantly challenged or even proven incorrect. Rendra Gupta is acutely aware of the enormous weight his theory carries. It possesses the potential to change not just our understanding of the universe but also the trajectory of all space research in the coming decades. Therefore, Gupta combines the tired light theory with another significant aspect of Zwicky's research: the potential existence of a new hypothetical particle in space. Gupta's perspective suggests that the universe, in addition to dark matter and dark energy, might harbor another entity coined exotic dark energy. This hypothetical energy is said to act as a damping force that slows down the movement of photons over time. Intriguingly, this could explain the weak cosmic microwave background radiation remnants of the Big Bang's first moments. However, Gupta's theory could invalidate the Big Bang theory. Despite its widespread acceptance, the Big Bang theory has always been a contentious topic among cosmologists and scientists, particularly concerning the origins of dark matter. Thus, the next few months and years will be crucial for Rendra Gupta, as his theory has the potential to fundamentally reshape our understanding of the universe. The revelation of a universe approximately 27 billion years old could eventually lead to the acceptance of new theories and even answer age-old questions about the universe's beginnings and future. Gupta stands ready to provide answers, just waiting for his theory to pass the tests of contemporary science. However, this doesn't necessarily imply that the Big Bang theory is obsolete. Rather, It could serve as the precursor to an even more revolutionary theory that might arise from Gupta's insights and the James Webb Telescope's discoveries. Whether the universe is 13.8 or 27 billion years old remains to be seen, but we can anticipate that new discoveries await us. We're fortunate to live in a time when we can witness these developments in space exploration firsthand and play a part in understanding the world we live in. It remains an open question how much of what we currently think we know will stand the test of time.